Okay, so here we have a table of values. We have 6 students comparing their tests before the final exam and then their final exam. So if we graph these ordered pairs, we're not going to do all of these ordered pairs right now. Well, that looks ugly. If you had been in class, then we would take the time to graph each point. I don't have time to do that in the video, but so 50 comma 42, I would go over 50 and up 42. So that's 40. So 50 comma 42 would be right there. 68 comma 60 would be up here. Okay, and these points end up, making something like this. Okay, so is there a correlation? Yeah, there's a positive correlation because I could make a line through a couple points, but they're all close to that line, and they're all going up and to the right, which would be a positive slope. So what is the correlation? It's positive. Okay, there's a positive correlation. Now, is there a relationship between these two things? That's a different story. Okay, a relationship means what you score on a test. Does that really have effect on how your exam went? Now, maybe a little bit, like you could say, I knew the material on the test, so that means I knew the material on the exam, maybe, but one doesn't have any direct relationship with the other. They're not really comparable, two comparable things. They're two completely different tests. One's an exam, one's a test, probably different material. So one doesn't affect the other. You get a 0 on one and 100 on the other. Really, there's no relationship there. I recommend watching this video that describes causation. This will be in the link for Google Classroom for the slide. It kind of explains things a little bit easier, what causes what to happen. So, for example, which one of these is causation and which one is correlation? Now, depending on how far you drive, how many miles you drive, that's going to affect how much gas you use in your car. Okay, so that one thing causes the other. How much I drive causes how much gas I use. Now, the number of hours of exercise versus the number of hours you use on social media. One doesn't really affect the other. It could affect it. So while I'm working out, I'm not using social media, but it doesn't have a direct effect on the other. So correlation, someone that uses more social media probably works out less. That's a correlation, but one doesn't cause the other. The amount of miles you drive based on, makes you lose more gas, makes you use more gas. That's causation. Now, percent, calculating percent. We don't have any students in the room right now, but so it says find the percent of students in this room with a black shirt on. So let's say there were 4 students with a black shirt on, and there were 20 students in the room. You would do 4 divided by 20. 4 divided by 20 is 0.20, and then you times it by 100. So that means 20% of kids in the class have a black shirt on. Okay. Find the percent of girls in this room with a black shirt on. So would probably be less. We're probably going to have 2 girls with a black shirt on in the class. So 2 out of 20 would be 0.1, and then you times it by 100. So that would be 10%. And these are just examples of scatter plots where these are types of graphs. This first one, exponential. This one is linear, and this one would be quadratic. So you might want to draw that in your notebook.